Hi guys, today I'm going to be talking about forces and specifically what that means in design technology. Now, I often get students who write about forces and they talk about gravity. Gravity is a force, but in design technology there are some specific ones that we're looking at. So I'm going to go through those and show you some practical examples. Tension, tension, tension. Tension is when something is pulled on. This piece of what I've got here, if I apply tension to it and pull it, it's under tension. Think about the belt on your trousers when you pull it on, if you're putting on a bit of weight. Or if you put your seatbelt on, when you pull against your seatbelt, that is tension. When something is tense and being pulled upon. Next up is compression. Compression is the opposite of tension. It's not being pulled, it is being squashed. So if I place this can under compression, it should squash. Now, very difficult to do with your bare hands because of the rounded shape. With your foot, on the other hand, the force of compression is much more obvious. Another great example of thinking about compression is when you sit on a chair. The seat of the chair is under compression. The legs are under compression. They're being squashed down. So when you're in a car seat, the seat is under compression. The back of the chair is under compression. The belt is under tension. Torsion. Now, a good example of torsion is rotary force. So if I was using my hand to open a jar by rotating one way and the other, that's torsion. If I am putting the bit into a drill, that's torsion, a rotary action. If I take this piece of wood and I rotate it like this, and it splinters, that is split under the force of torsion, rotary twisting. Thinking about like wringing out a towel. Bending, bending, bending. The force of bending is where something is literally bent. So if I were to make a very thin bridge that was not supported properly and apply weight to the center, it would bend, okay? So, but the 2 points would stay the same, but in the center, the object would bend and the force would be bending. Whereas if I place the same piece of wood sideways like this, and I try and apply that force to it, there wouldn't be any bending. Okay, so when you're thinking about structural integrity of design, you need to factor in things like bending. Finally, on the ones in the AQA specification, is shear force. Now, think about garden shears. Here's another example with two bits of wood. This motion here, okay? Those two pieces are moving across one another flat, okay? Like a pair of shears, a pair of scissors. Shear force is when two things move past each other, and a good example of that is literally cutting something with a pair of scissors, or think about garden shears, yeah? When I go to the hairdressers and get my hair chopped. Shear force. When might that happen structurally? If you think about a bridge, and you've got two pieces next to each other, and they are bolted together, all of those bolts that are sit across the surface are under shear force, because all of the force is not from compression, it's not being squashed, they're not being bent, they're not being twisted, they are next to each other and the force is being applied in a straight line down. So it broke off, it'll break off like that. Okay, that's a brief introduction and explanation of the forces that are covered under GCSE. Remember, gravity is not the answer we're looking for. Tension, compression, torsion, bending, and shear. I hope that's been helpful.